this last section of trigonometry, we're looking at drawing graphs of trigonometry. So what we want to do is look at for different angle values and then plotting the different angles according to the sine and the cos and the tan on a number plane. So when we're looking at these, what we're going to do is put the angle along the horizontal, and then the vertical is going to be your sine, cos, or tan value. So I've already done most of the work here, okay? So we've got the angle along the horizontal, and then the vertical is going to be sine. So basically all we're doing for this exercise is we're going to plot the points. So each of these values I've worked out by putting in sine of 30, sine of 60, sine of 90, and so on. So I've just put those numbers at approximately 2 decimal places, 1 decimal place where needed. So if I were to go plot these points, this is the type of, this is where all your dots will sort of turn out. So what we can now do is we can draw a nice smooth curve through each of those points. So it's going to come up through these points, then come down, and then back up. So I know for, I didn't put in an a theta equals 0 value here, that was my neglect, but sine of 0 is 0, so we know that it's going to pass through the origin. So this would be the graph of sine theta. So if I wanted to write y equals sine x, so your horizontal is your x axis, y equals sine x, that would be what the graph looks like. Now we could go further than 360 degrees. We can also go less than 0 as well. And what you'll notice is this graph is going to just continue. And so sine's what's also called a wave graph. Okay, so you can see it's going up and down. So you've got your waves here. Okay, one really big place where we do use a lot of sine graphs is when we're looking at tides, when we're looking at oscillation, so when things are going around in circles, when you're looking at waves in general, like when you're looking in science as well, like when we're talking about electricity, how electricity moves, and also in sound waves, anytime we're talking about waves. When we come to cosine, I've done exactly the same thing. So I've filled in the table of values, and then I've gone and drawn the graph, plotted the points. So when you plot the points, you can see this time it's starting at 1. Oh, so that should have been cos. If you could change that. So cos theta, you can see I just copied and pasted my table. So cos theta, it's going to start at 1, okay, because cos of 0 is 1, and then it's going to come down and then back up. So if we go and join that together, it comes down, and then it comes back up. And so you can see that's pretty much what's called one wavelength. So it's sort of gone, like how far it's gone in order to get from the beginning to back to the beginning. Okay, so it started at 1, it's gone down and then back up to 1. And then what's going to happen is if I go further than 360, that's just going to be a repeat of this again. Okay, and it's going to keep going up and down and up and down. So when you look at sine and cosine, you can see they are kind of related to each other. So if I just zoom out a little bit here, okay, what you might notice is this bit of sine is actually the same as this bit of cosine. So sine and cosine are actually translations of each other, okay? So that's a nice pattern that you might be able to see there, okay? But it's sort of got the same pattern the whole way through, okay? With our sine graph, if we start at the origin, okay, and we end at the origin, that's what's called one wavelength. When we get to tan though, the graph looks a little bit different, mainly because there are certain values that we can't have. So if you try to put tan of 90 or tan of 270 into your calculator, you'll notice it comes up with a math error, okay? And that means that those values don't exist. We sort of talked about this earlier when we were looking at the quadrants, because we established that tan theta is sine theta over cosine theta. So that was one nice relationship we saw between sine, cos, and tan. Now, if we have 90 degrees, what you'll notice is cosine of 90 is actually equal to 0. So what's going to happen is we're actually going to be dividing by 0, which we can't do. So that's why we have discontinuities, or we have values that we can't have there. And in actual fact, those are actually going to be asymptotes. So remember, an asymptote is a line that the graph is going to get close to, but it's never going to actually touch. So when I go and graph these values, now just notice in this graph, the values on the y-axis actually go up to 2. Okay, so if you look at these values, they actually go bigger than 1. Okay, with sine and cosine, it was only between -1 and 1. It doesn't actually go any further than that, but with tan, it actually goes a lot further. So what's going to happen to this graph is, again, tan of 0, let me just fix that one up again, tan of 0 is 0, okay, because you've got sine of 0. So we've got a point at the origin, and then what's going to happen is this graph is going to come up, and it's going to keep going up this way, and then it's going to keep approaching that asymptote, okay? So it looks almost like a bit of a little bit of parabola-ish, cubic-y sort of thing. When you go to the next bit, you'll see it looks kind of cubic, but the only thing that's different from a cubic and what we've got here is there is restrictions. So this section of graph is only going to be between 90 and 270. So if I start from 100 now and draw it down, this graph is going to go this way, and it's going to keep approaching 90, okay? Get closer and closer to 90, but it's never going to touch it. On the other side, it's going to come up, and it's going to keep going up that way. And then if we look at the part between 270 and 360, it's just going to be a graph going down that way. And that's the graph of tan. Now, in the textbook exercise, basically what you're doing is we're looking at these graphs and using it to find certain values. So these are values that we use to draw the graph. If I wanted to say, for example, let's go back up to cos, and let's say I wanted to find, let's go to sine. Let's say I want to find the value of sine 15 degrees, okay, or something like that. We can see 15 is going to be right here. So what we can do is to work out sine 15, we can actually use the graph that we drew in order to work out the value. Now, obviously, because this was a graph that I drew, it's not going to be as accurate if we were to use any graphing software, okay, or if like we were given a diagram to scale, then we could work it out much easier as well. Even better, you just really use a calculator. Okay, so the main thing here is really just to take away that the general shape of sine and cos and tan, and then later on in year 11 we will do a little bit more with the trigonometric graphs, but at the moment it's just recognizing that we can graph them in these ways. Okay, so those are your different types of graphs. Now, a couple of key terms, I know it wasn't in your notes, if you could write this in. Some key terms that you will see a fair bit of. Okay, some of this you might have seen in science already. We talk about amplitude. The amplitude of a graph is the maximum displacement from a certain level. So this word, the amplitude, we really only talk about when we're doing sine and cosine. So when we look at sine and cosine, what we're looking at is how far can we go, either up or down, okay? So in this case, with sine x, okay, or sine theta, the highest point is 1 and the lowest point is -1. So what you'll see is the amplitude is the distance from the horizon, from where it's sort of going around, up to the highest point of the graph. Okay, so the amplitude for this one is 1. Likewise with cosine, the highest point from the reference point, so this is your reference point because this is where it's going up and down around, the amplitude is also going to be 1. When we look at tan, we can't actually work out an amplitude because this graph is just going to keep going up and up and up and up, and it's never going to stop. So there's no amplitude. We don't really talk about amplitude when we're looking at tan. The other word that we look at is period. So the period is the number of degrees, okay, or the length along the x-axis to make one cycle. Okay, so one cycle is the section that you would be able to then copy and paste and paste and paste to get exactly the same graph. So we sort of talked about it up here. If I've got this graph of sine here, I could continue this and it's just going to keep going up and down and up and down. So the period of this is this distance until this graph is going to start again. So the period of this sine graph is 360 degrees. When we look at cosine, again, we talked about it goes down, back up, it's going to go down and then back up, and it's just going to keep doing that. But the place that it resets is from 0, again, up to 360. So for sine and cosine, it follows the same values. With tan, however, again, it's a little bit different because we've got this part of the graph. If I went to the negative side, then the negative side would have looked like this, and then we'd have another asymptote there. Okay, so what's actually happening here is this part and this part, okay, is actually what we're repeating, because if you look at this section's exactly the same as this section here. Okay, or you could look at it as between 90 and 270, we're going to take this graph, and we're going to repeat it, and then repeat it, and then repeat it, or we can go the other way as well. Okay, so when we're looking at tan, the period is between 90 and 270, so that distance is 180 degrees. So when we're looking at amplitude, that's only for sine and cosine, okay, and for our particular graphs, it's 1. When we're looking at period, sine and cosine is 360 degrees, whereas tan is actually 180 degrees. So there's a couple of questions to have a look at. With these questions, you're doing them based on a graph that you're going to draw, okay? Or if you want to, you can always pop onto GeoGebra or Desmos or somewhere else, and then you can sort of generate a graph and you can solve your problems from there.